Welcome to one of the first series of solutions. This is a series of solving basically PQs, past questions that we have for this semester, the second semester. Okay, so I'll be starting with this particular course, numerical computation in physics, and I'll be starting with the fixed point iteration method. So let's get straight to business. And the first thing we need before we start any question on this is to have our calculator by our side. Our calculator is very, very important. So let's run through this question. So they said a partial sum of the Maclaurin series is given by f of y is equal to this equation: 1 minus 1 over 4y squared plus 1 over 64y to the power of 4 minus 1 over 2304y to the power of 6. And if this transformation is given, if this equation is transformed, we can transform it into y is equal to g of y equals to 4 over y minus y plus y cubed over 1 over 16 minus y to the power of 5 over 576. So find the roots of the function correct to 6 decimal places, starting with a guess value of y naught is equal to 2, and we have to stop after 5 iterative steps. So basically, the fixed point method gives us our original equation f of y, and we have to transform it using a very simple mathematical approach into y is equals to g of y. And this particular question, we were given our f of y, and luckily for us, we were also given our g of y. But just in case we are not given g of y, let me quickly run through how we can obtain our g of y for this particular question. This is our function once again. This is the Maclaurin. This is a part of the Maclaurin series we want to evaluate. So let us remember that this function is equal to 0. This function is equal to 0. So I can have, okay, first of all, I would like to divide through by y. I will divide through by y, and I'll be having 1 over y minus 1 over 4 y. Okay, that's by dividing through by y, plus 1 over 64 y cubed minus 1 over 2304 y to the power of 5 equals to 0. So this was obtained by dividing through this equation by y. 1 divided by y squared divided by y gives us y. Y to the power of 4 divided by y gives us y cubed. Y to the power of 6 divided by y gives us y to the power of 5. Then 0 divided by y gives us 0. So that's pretty much all you have to do whenever you see questions like this. Whenever you see, especially polynomial questions, you just divide through by the independent variable, which in this case is y. So I will now look through that, which one is standing alone. Okay, now we can see that this y is to the power of 1. So all I have to do now is to make this y the subject of formula, and I'll be having 1 over y plus 1 over 64 y to the power of 3 minus 1 over 2304 y to the power of 5 is equal to 1 over 4 y. So by completing this, I can just multiply through by 4. So I'll be having 4 over y, that's by multiplying through by 4, plus 4 over 64 y to the power of 3 minus 4 over 2304 y to the power of 5 is equal to y. So I have successfully obtained my g of y, but just to further break this down, I can write this as 4 over y plus 1 over 16 y to the power of 3 minus 1 over, let's see, 2304 divided by 4 is 576. So I'm having minus 1576 y to the power of 5 equals to y. So I have obtained my g of y as given in this question. So this is our transformed equation, y equals to g of y, where our g of y is equal to 4 over y plus 1 over 16y to the power of 3 minus 1 over 576 raised y to the power of 5. Okay, so what's the next step in this now? So the fixed iteration method just tells us a very simple formula that this same equation, y is equals to g of y, with a little bit of catch that we say yn plus 1 equals to g of y sub n. Alright, so why this formula? Because we are performing an iterative procedure, we have to include this n plus 1 and n, where this n are the number of the initial value that we have at that particular moment, the value that we have at that particular moment. So if you look at the question, we're given a value y naught is equal to 2. We're given a value of y naught is equal to 2. This is called our initial guess value. And knowing this, we can now see that our n in this case can be equal to 0. And we were told to repeat this iterative method for 5 steps. So I'm going to start with first step. You may wish to change this language and just say first iteration. It doesn't take anything away. First step, first iteration means the same thing. First step, first iteration. So the first iteration tells us to start with our n is equal to 0. So if my n is equal to 0, I'll be having y sub 1 is equals to g of y sub 0. Alright, so our y sub 1 will be equals to, putting in our g of y sub 0, I'll be having 4 all divided by y sub 0 plus 1 over 16 y to the power of 3 sub 0 minus 1 over 576 y to the power of 5 sub 0. So what is my y naught? My y naught is 1. y1 is equals to 4 divided by my y naught is given as 2 plus 1 over 16 times 2 to the power of 3, because my y naught is still 2, minus 1 over 576, 2 to the power of 5. So I'm having y sub 1 is equal to 2 plus 8 over 16, right, minus 32 over 576. So if I put all of this into my calculator directly, so I'll be having 2 plus 8 over 16. I would recommend this type of calculator because it helps to take care of fractions too easily. Minus 32 over 576, and this gives us 22 over 9 directly. So, but we're told to work with 6 decimal places. So we're having 2.444. All right. So we're having our y sub 1 to be 2.4444. Is it complete? 6. Okay, 71. All right. So I'm sorry for this place. I would advise we add 6 zeros also. Yeah, that's for. Yeah. All right. So this is our y sub 1. So then we'll now go on to our second iterative step. So based on the fact that we are going to be having 5 iteration method, iteration steps, I'll be going on to the next iteration. Remember that the first iteration was when n is equal to 0. So now we'll continue our second iteration with n equal to 1 using our initial formula y sub n plus 1 is equal to g of y sub n, right? And remember what our g of y sub n was, and this is our y sub n plus 1, and we have obtained our y1 as 2.44444. Alright, so our y2 would now be 4 divided by 2.44444. Okay, I can do one more 4 plus 1 over 16 into brackets 2.444444 all cube minus 1 over 576 2.44444 to the power of 5. So likewise, I'll just impute it into the calculator directly by saying 4 over 2.444444 plus, okay, another fraction, 2.444444, okay, I think I have an extra 4, all cubed, divided by, okay, I think this was a mistake, divided by 16, then minus another fraction, 2.444444 to the power of 5 divided by 576, and that gives us our next iteration to be, our y2 is therefore 2.397735. Yes. So then onto our third iteration, you can see that we are gradually closing in, because one of the most important thing is called convergence. Convergence. We have to see that our values converge. So our third iteration, or our third step, is going to be when n is equal to 3, and that will give us, when n is equal to 2, and that will give us y sub 3 equals to g of y2. Alright, so we'll now be having y sub 3 is equals to 4 over y2 plus 1 over 16 y2 raised to the power of 3 minus 1 over 576 y2 raised to the power of 5. So similarly, just like how we've been doing the rest, just put in your value, the previous value we got. That's 4 all divided by 2.397735 plus, always remember to show all of these workings, plus 1 over 16 into brackets 2.397735 all to the power of 3 minus 1 over 576 into brackets 2.397735. Remember, if you have any questions, you can always leave it down in the comment section. Alright, so this is what we have for our third iteration, and remember, you can always put this into your calculator directly. So putting this into the calculator directly, I can just, okay, there is something I can tell us to actually do as a means to ease our burden. Just type in your previous answer, 2.397735 equal to, now this is your y2. Then all you have to do from here on is just get your fraction, 4 divided by answer, instead of typing those long things, because they get tiring actually, plus answer raised to the power of 3 all divided by 16 minus answer all raised to the power of 5 divided by 576, and we get our y3. Our y3 is 2.392208. So this right here is our third iteration. Almost done. We were asked to complete for 5 steps, and we are currently in the 4th step. So the first step is when n is equal to 3. So you can see that we're going to be stopping at the 5th step, which is going to be when n is equal to 4. So our 4th iteration gives us our y sub 4, which is equal to g of y sub 3. And that gives us y sub 4 is equal to 4 over y sub 3 plus y sub 3 cubed divided by 16 minus 1 over 576 y sub 3 to the power of 5. Now, all of this is quite pretty easy because our y sub 3 is equal to 2.392208. Okay, so our y sub 4 is then equal to y divided by, remember that what we're trying to do is we are trying to refine our original guess value until we get something that has a negligible error compared to the actual answer that we are expecting. So this is 2.392208 cubed divided by 16 minus 2.392208 to the power of 5 divided by 576. So our y sub 4 is equal to, as I said, your calculator helps you the most here. So I'll just put in my y sub 3 here, 2.39. I hope you can see the calculator. 2.392208, and this is going to be equal to, so I have my answer stored. So I'll just be having 4 divided by answer plus the answer cube divided by 16 minus the answer to the fifth power divided by 576. Can you see how easy that was? We were able to reduce the time which we used to type in all those long numbers and just use answer straight up by just typing it once. So if I press equal to, I get my y sub 4 to be 2.3916 this 3 97. All right, so to 6 decimal places. This is not from my head, definitely it's from the calculator. Yeah. 1 2 3 4 5 6 decimal places. We have 9 approximates to, you round up by adding 1 here, so you have 7. All right, so this is our y sub 4 and this is our result after the fourth iteration. You'll see that there is no much difference between y sub 4 and y sub 3, especially to the second decimal place, right, or even up to the fourth to the third decimal place, because this rounds up to 2.392 and this rounds to 2.392 also. But let's just, so you can see I'm actually getting closer to a final answer. But let's just go on to the fifth step and we can end our iteration. I hope we have been following and we understand everything. So in this case, n is equal to 4, and we're having y sub 4 is equals to g of y sub, y sub 5 is equals to g of y sub 4. And our y sub 5 will then be equals to 4 over y sub 4 plus y sub 4 cube divided by 16 minus y sub 4 to the power of 5 over 576. All right, so we are just using the initial transformation that we've always had from the beginning. I hope you remember. Okay, so I know my y sub 4. It is given as this. Yeah, this is my y sub 4. So I'm having 4 divided by 2.391697 plus 2.391697 cube divided by 16 minus okay 2.391697 to the power of 5 divided by 576. And this is the last lap, so I am going to congratulate us for staying through this video to see the end of this. So I will just put in my y sub 4. Just put in the usuals that we have. Okay, my y4 in this case is 2.391697. Please, you have to make sure that everything is correct. So I'll put in my equal to sign. Right, please, I'll be saying this is my y4. I'll be putting everything into my y5. So I'll be having my y5. So I'll be having my 4 all divided by answer minus, okay, plus my answer cube divided by 16. Then minus my answer to the power of 5 divided by 576. Please, I hope you all see this. We don't want to make any mistakes at this point because we cannot come all the way and just come and bring it all up. So equal to, and that gives me my answer of 2.391651. Yes, and this gives us this answer. And if we look at this, you can see that if we are approximating this to the nearest possible 3 decimal place, for the past 3 steps, we are getting the same answer, 2.392, 2.392. And if you look at the error between these two, I think is from the, if you look at the approximation of y5 and y4, you'll see that to the nearest 4 decimal place, they are correct, right? So we are done. This is 5 iterations, so we are done. Thank you for sticking with me, and I hope you understand. Please, if you do not get any part of this, you can always leave questions in the comments section. Thank you very much.